Hello, welcome back to the video series. We continue to review the Understanding Construction Drawings textbook. This video is about Unit 24, and that is cornices. So after completing this unit, you'll get a few important skills. You'll be able to describe the cornice construction that is shown on the set of drawings. Then you'll be able to list the sizes of the individual parts of the cornice and describe the provisions for attic or roof ventilation. And that is in accordance with the construction drawings. So we'll take a look at the cornice returns and ventilation here. So please stay tuned. And it's important to allow ventilating air to flow along the bottom of the roof from the cornice to the upper ends of the rafters. And so when we take a look at the cornice returns, any type of construction described for cornices can be used for the rake. So when a sloping cornice is used, the fascia and soffit follow the line of the roof up the rake. When a level box cornice is used, a cornice return is necessary. And this is the construction that joins the level soffit and fascia of the eave with the sloping rake. So please refer to the images in the textbook, and you can see how it's actually done. So you can see the photographs from different houses, different structures, and you will be able to see the diagrams, how that is connected and how that is graphically represented in the construction documents. So the style of cornice return is usually shown on the building elevations. And although good architectural practice requires details of all special construction, many architects do not include detail of cornice returns. And the carpenter is expected to know how to achieve the desired results. So here in the textbook, you can see the details, you can see the section through cornice return, and you can see the framing for cornice return and also all the details. So let's talk a little bit about ventilation. The cornice must allow for ventilation of the attic or roof. Attic or roof ventilation is necessary in both hot and cold weather. Without ventilation, the air in the attic becomes stagnant because it's trapped and unable to circulate. In hot weather, this stagnant air builds up heat and makes the house warmer. Hot, stagnant air can hold a large amount of moisture. When this moisture-laden air comes in contact with the cooler roof, the moisture condenses. The condensation can reduce the effectiveness of the insulation. Condensation can also cause the wood in the attic to rot. That is why this is so important to provide the ventilation. Also, there is a green note here, as in every chapter of this textbook. Please refer to them. They can help us understand how to make the construction sustainable. So this particular one describes a few things. So in some areas, especially where houses do not have basements, it is common to locate furnaces and water heaters in the attic. Combustion equipment such as gas-fired furnaces and water heaters should not be located in a condition should not be located in a conditioned attic unless it is a separate space that is sealed off from the rest of the conditioned spaces of the house. A conditioned attic would be one in which the insulation is placed against the roof instead of the floor. If backdrafting occurs, carbon monoxide can escape into the surrounding space. In addition to the danger posed by carbon monoxide, the backdrafting can cause water vapor from burning fuel to remain in the attic and increase the chances of condensation forming in the attic. So please pay attention to this. And attic or roof ventilation also helps prevent ice buildup in cold climates. Without ventilation, the heat from the building melts the snow that falls on the roof. As the melted snow reaches the overhang of the roof, it refreezes. Eventually, the ice dam may build up. The ice dam can back up newly melted snow, causing it to seep under the shingles. So another diagram here showing how that is building up. So ventilation is created by allowing cool air to enter through the cornice and exit at the ridge or through special ventilators. And you can see that here in the textbook. There is a section showing that using I-joists for rafters allows for greater rafter length and conserves natural lumber resources. But such framing requires construction details that are not normally required with solid lumber. So please take a look at the necessary provisions for roof framing here, and the heated air can be allowed to exit in one of three ways. So some buildings have a ventilated metal ridge cap. This way, um, this way it's shown on the building elevations or on a separate detail. When ventilated ridge is used, an opening is left in the roof decking at the ridge. Metal roof ventilators can be installed in the roof, and ventilators can be installed in the gables. Metal roof ventilators and gable ventilators are usually shown on the building's elevations only. So please pay attention to that. And this wraps up our unit 24. Thank you so much for watching. I will see you in unit 25.